This is a review from yesterday. If x equals -2, go to the graph, find -2 on the x-axis. So -2 is right here, right? -2. Then draw a line intersecting the graph of the equation, the graph of the function, and the graph is going to be intersected at this point here where y equals to 1. So the answer here is y equals to 1. So on this, I'm not going to do this. On the first part, when you have x, you're only going to have one y. For each x, only one y, because those are functions. And the definition of function is that if you have x, you can have only one y for each x. The second part is a little bit harder because you can have more than one x. For each y, you can have more than one x. So let's check this one here, this. Y equals f of x equals 0. So go to 0, go to the graph, on the y-axis find y equals 0, is right here, right? Draw a horizontal line, so draw a horizontal line, and you're going to find the intersection, and in this case, in this graph, for this function, you're going to have two different intersections. Here, x equals -4, and there x equals 4. So x equals -4 and x equals 4. That's it. Review from yesterday. Now let's talk about the topic of today's class. And we will apply this review in a few questions on the quiz. But most of the questions are about the topic of today's class, which is about domain of a function. So today we are talking about domain of a function. Let's read here some definitions, some explanations, but actually, as usual, we're going to understand when we work on examples. We will actually be careful when defining the domain to avoid a few situations, a couple of situations that I'm going to show here. One of the situations, this one here, is exclude values of x that makes the denominator of a fraction 0. So let's say you have a fraction, numerator of denominator, and this is a function. We don't want that this denominator to be equal to 0, because it's going to make the fraction undetermined or undefined. So you don't want this, right? You don't want this. You want to avoid. You're going to exclude any values of x, any values of the variable that makes the denominator equals to 0. Another situation, and you're going to have another situation here, is when you have square roots. And if you have a function equals the square root of something, a blank, this something here is not supposed to be a negative number, because if it is a negative number, there's no real solution. So we will exclude from the domain anything that makes this expression inside the square root a negative number. Okay? Those are the two situations, the two things that we're going to work today. To find the domain, to exclude from the domain the values that causes that kind of situations. Examples, and now I think you're going to be understanding. Examples, write the domain in interval notation. Now let's check this first example. We have here an example of a fraction, right? A radical expression. And another example of the square root. So we have a fraction and a square root. The first one, let's work the fraction first. F of x equals x plus 7 over 2x minus 1. The denominator kind of doesn't matter. What we are looking for is the numerator. I mean, the numerator doesn't matter. We are looking for the denominator. And the denominator must be different from 0. We don't want the denominator to be equal to 0. So write down here 2x minus 1 different from 0. What's going to make this denominator different from 0? So we need to find the value of x that will make this equals to 0, and you're going to exclude from the domain, right? Add 1 on both sides, add 1 on both sides of the equation, then you're going to have 2x different from 1. And divide both sides by 2, divide by 2, x different from 1 over 2. This is what we are avoiding, this is what we want to exclude from the domain. For that, you're going to actually apply a template. Let's say it's a template that you're going to fill out, and the template looks like that. The domain equals negative infinity, blank, okay, united with blank, infinity. This is the template, this is how you're going to answer this kind of question. The domain is going to be from negative infinity to 1 over 2, united with 1 over 2 all the way to infinity. So this is the answer. This is how you will define the domain, excluding just one point, excluding the point where x equals 1 over 2. Make sense? Any questions? No questions? And don't worry, because we're going to work on the quiz together. Maybe if you're not quite sure if you understood this, we are going to apply this on the quiz. I think you're going to be able to understand this on the quiz. And Marty is asking here, good morning, apologize for being late. My internet connection, oh, no worry, no worry. Don't worry, Maddie. Just make sure you open the assignment. And Kalia, I'm sure you'll get it later. Yeah, it's sometimes it starts a little bit confusing, but when we work together on the quiz, it gets better. Let's check the other situation here. The other situation is this. We have k, and we have only these two situations, with no denominator and with the square root of t plus 4. We don't want this t plus 4 here to be negative. We want this to be equals to 0 or positive. So we want t plus 4 to be greater or equal than 0. That means t greater or equal than negative 4. Okay? T is supposed to be greater or equal than negative 4. No, Jacob, it doesn't matter. The numerator doesn't matter. You don't need to be worried about the numerator. We don't need to get rid of the numerator. We're just going to work on the denominator to avoid that the denominator is actually to make the denominator different from 0. We never want to have a denominator that's equals to 0, because your expression becomes undetermined or undefined. Okay? Now let's go back to the square root. We don't want now this to be a negative number. And now the template is going to be brackets, leave this blank to infinity, parentheses. This is the template, how I'm going to answer this kind of question. And here you're going to fill with the number from negative 4 all the way to infinity. This is the template, the way you're going to answer this kind of question here about the domain. Okay? So keep this. Actually, if you want, if you can, you take a picture of this or make a screenshot and save this in your records. This is the step-by-step. Any more guesses? And Jim is how did he forget to fill out the numbers? He was well prepared for this presentation. He prepared the PowerPoint, he prepared the graphs, he studied about everything that he is supposed to speak, but then the graph doesn't have the numbers. There are some missing numbers. And McKinney is typing here 77, 77. We have 77, 78, 69, and 77. Most of the answers are 77. Any more answers? Any more guesses? And we're supposed to have more. We have more people on the meeting, we have more students on the meeting, and you can type, you can even agree with someone, or you can just say, I disagree, or you can say, I don't know. I just need your participation here. Okay, let's calculate, let's find out, because I want to go to the quiz, to work on the quiz, to have time, enough time to work with you on the quiz. Let's find out. We can assume this graph is a linear growth, right? Because you can check it out, and it looks like a constant growth. And if you draw a line, you can see this is going kind of as a constant and linear growth, and therefore we can assume this is a linear function. Okay, this is a linear function, and actually 2023, the year 2023, is going to be exactly at the middle of 2020, which is 56, and 2026, which is 96. And 2023 is right here in the midpoint, right in the middle. And we're going to learn later how to calculate it, how to find the midpoint. Midpoint. The coordinates of the midpoint is what we're doing here. There's a formula, we're going to see it later, but basically it's the average. You're going to get 96, and you add 56, and you're going to divide by 2. If you do this math, 96 plus 56 divided by 2, you're going to find 76. 76 is the right answer. 76 is the right answer for the bell work. But don't worry, because 77 is also a very good answer if you are in front of your boss, if you are feeling the pressure. 77 is a perfectly good answer. 78, very good answer as well. 69, kind of, yeah, you can make 69 is close enough. So in this situation, if it's a real situation, right? If it's a real it's a real life scenario that you are in this real situation, if you answer 77, 78, that's perfect. That's good enough. Okay? You just need to be confident and say the number with confidence. All right, the right answer, if you want to have the grade for the quiz, is 76. But thank you, Jacob, thank you, Kalia, Joniel, Keisha, Ewil, Makina, and Maddie for your participation. Thank you. Your answers are perfectly good, are close enough, and your boss is going to be happy. Moving on, let's work on the quiz now. Let me just clear this up. 76 is the right answer. And working now on the quiz. The first part is the review, right? And I'm gonna do just real quick here. Let's say x equals 0. Go to the graph, find 0, then find the intersection on the graph, and the answer is going to be y equals 1. You're going to have only one y for each x. And you're going to do this on A, B, and C is just the opposite. You're going to have fx equals -3, and this is y. So you go to the graph, -3 is right here, draw a line and find the intersection. And now you're going to have two x's. Okay? This is how you do for this graphs, this review. Let's actually go to the topic of today's class. This is the the questions that regards today's class. Letter G. K of x equals x minus 3 over x plus 6. We don't want the denominator to be equals to 0, right? We want to find the domain. We're going to exclude from the domain anything that makes the denominator, in this case here, equals to 0. So let's write down here 6 plus x plus 6, different from 0. We don't want it equals to 0, different from 0. That means x is going to be different from negative 6. That's the number that we want to exclude from the domain. We're going to delete this number from the domain. And the template that you're going to use here is d equals from negative infinity, blank, united, capital U, blank, infinity. Okay? This is the template. And that highlighted is the answer that you're going to type on your quiz, on your forms. Fill out with the number that you want to get rid of and remove from the domain, and that's the answer. Okay? For letter G, the answer is going to be parentheses, negative infinity, comma, negative 6, parentheses, united with negative 6, comma, infinity. And this means you are removing just the points, just this point here where x equals negative 6 from the domain. Make sense? Now try by yourselves to solve all the other questions. You don't need to be worried about K and L. I'm gonna remove this. This is not working. This is not good. Work on H, I, and J, and after that we're gonna work on M. Okay. And Noelia is asking, can you help with P? Yes. Let's go to, so work by yourselves on the questions, and then I'm going to show M, how to work on M. And Noelia is asking about P. Oh, let me just give you a couple of minutes, okay, Noelia? Just a couple of minutes, let the other ones catch up, and then we go over P. Just one couple of minutes. So on P, let's work here on P. We don't want, when you're working with the square root, we don't want this to be a negative. So the expression that's inside here, the square root, needs to be equals to 0 or positive. That means 4 minus 2x greater or equal than 0. Okay? And in this situation, we will, and this situation here, what's going to do first is going to apply addition property. Let's add 2x on both sides. See, we're adding 2x. So 4, negative 2x plus 2x, 0, greater or equal than 2x. We can switch sides. But we need to flip. Don't forget to flip the inequality symbol, right? So we have 2x is less or equal than 4. So we switch sides, but we have to flip the inequality symbol. And actually, you can divide both sides by 2, and then you have x less or equal than 2. The domain is going to be from negative infinity all the way up to 2 with a bracket. So it's less or equal than 2. That means it starts on negative infinity, and the domain will stop on x equals 2, and from from this is the domain. This is the domain. This is how you answer. And everything that's not here is because it makes the expression here a negative, and we want to avoid it. And Kalia is asking to work on B. Yes, Kalia, on B, the graph, right? The graph. So this is P, which Noelia was asking, P. Now let's go back here to B. B. On B, we're going to have, this is x, x equals 1. X equals 1. So go to the graph, and x equals 1 is this point right here. Is a point that's actually intersecting the graph already, it's intersecting the function. So you check the coordinate of this point, and the coordinate is the coordinate of the origin is y equals the coordinate. It doesn't show up here, but it's 0, right? This is the coordinate of this point, 0. Y equals 0. And that's going to be B. Oh, Noelia, don't worry. Actually, there's a mistake of forms. And I will write down here, going to give you the credit for this. I think I actually going to need to give all of you the credit. You just can leave this as a blank. You can leave this as a blank because it's wrong. It's wrong in forms. It's something wrong in forms.
Mr. What was B?
B. Here. B, y equals 0. See? And B, y equals 0. For x equals 1, you can have y equals 0. And let me see, we have